Hello and welcome to another Ginger Mathematician video. We're going to go through all you need to know on percentage calculations coming up on most of the papers, particularly paper 4. Right, let's get started. So Alana pays a weekly rent of $255 for her apartment, and the price of this weekly rent is 2% higher than 1 year ago. And we need to find the price of her weekly rent 1 year ago. And I always use the tense of the question here to help me. So we've got ago, so this is in the past. So essentially we want to work out what it was before, and she is now paying this particular weekly rent. So we know then that if we've got 100% and we add 2% to this, well, we have 102%. So currently Alana is paying 102% of the rent that it was 1 year ago. So the way I like to format this, and you'll see this for lots of questions in this video, is I write down what I have. So 102% is equal to $255. And what we want to find is that original amount, that original 100% from before. So by structuring it in such a way, it then lends very nicely to the calculations that we're going to do. So we need an intermediary step. We need a step in the middle. And the way we can do this is a so-called unitary method. So I'm going to divide both sides by 102. If I do that, well, 102 divided by 102 is equal to 1. So the key thing here is to try and get it into 1%, and then we can then work out 100%. So if I want to go from 1 to 100, well, I just times it by 100, doing the same on both sides. So my calculation here to actually work out the correct answer is to take the $255, get that 1% by dividing by 102, and then multiplying by 100. Now, you'll really need your calculator for this video because we're going to do tons of work using it, so make sure you have it ready at home. Okay, so I've got my calculator here, and I'm just going to go through the operations we've just done. So we do 255, so 255 divided by 102, and then we're going to take that and times by 100, giving us our final answer of 250. Again, you don't need to write down the intermediary step if you don't need to, but it was 2.5 if you need that there as well. So our final answer here is $250. Always do a common sense check in this kind of question. So she had a rent of $250. It's now 2% higher, which is then 255. So if you're never sure in the exam, you can always check by going logically through the question to make sure you're getting this correct answer of $250. Now, Alana, unfortunately, can only pay 1 full year's rent in advance. Now, 1 year is 52 weeks. That's important to note. She will receive a discount of 3% on each of the weekly rent of $255. So calculate the cost of paying the full year's rent in advance. So the first thing I'm going to do here is I'm going to decrease, as we're going to assume she gets the discount, decrease $255 by 3%. Now, there's a couple of different ways that we can do this. The method I like to use here is if you've got 100% and we've got a decrease of 3%, so taking away 3%, that leaves us with 97%, and then converting that to a decimal, which sometimes calculators you don't need to do this with, you get 0.97. So a really easy way of working this out using what we call the multiplier, this 0.97, is just take the 255 and then multiply by 0.97. So I'm going to just do that on my small calculator here. If we do that, we're going to get 247.35, and there's no ... because it's an exact value, and 1 year is 52 weeks. So notice that key underlining here of the question is really, really useful. So the cost is going to be this discounted rent of $247.35, and then we're going to multiply by 52 weeks. Now, good thing about keeping it in your calculator here is we can just press times 52. It will take the previous answer and use that. And if we do that, we're going to get then the decimal of 12,000, just write this down, 12,862.2. Now, whenever you're doing a money calculation style question, make sure when we're writing this, $12,862.20. We should always be working with two decimal places whenever we do a money calculation. And we move on to a more problem-solving style question here. So 1 week, Bev, new person here, Bev, she earns X amount of dollars. She spends a quarter of these earnings on rent and 2/9 on food. And then she spends 1/3 of the remaining money. Now this is in bold, so whenever I see something in bold on the iGCSE question, I'm really going to pay attention to that. She spends that remaining money, or third of it, on clothes and then saves the rest. She saves $152, work out the value of X. So I'm going to ignore the X for the time being here, but I'm just going to be working out how much money she's taking off and what fraction is actually being saved here. So my focus here is to work out the fraction to be saved. I'll talk through that at the moment. So say you've got a full amount of money here, and we're going to take off a quarter and 2/9. So the first thing I want to do here is work out a quarter plus 2/9. Now you could of course use non-calculator methods here, but this is a calculator question. So all I'm going to do on my calculator here is simply type in 1/4 plus 2/9 and see what happens. This is something I really encourage you to do on any calculator, any scientific calculator. So I'm going to use the fraction button here. I go 1/4. Of course, on a non-calculator paper, you'd have to do this manually. But if we have the calculator, why not let us do the simplifying for us? So look, go equals, it'll give you that fraction. It'll give you that directly of 17/36. So whenever you are doing a fraction question with calculators available and it says you can use it, do use it. It will save you lots of time in the exam. Notice it's only a 3-mark question, so you need to save time where you can. So if she's spending then 17/36 of this X, then what's remaining, I'm using the word in the question here, well, we take 17/36 away from a whole one. And if we do that, well, we can do that in our head here. We get 19/36. Again, remember, 1 is the same here as 36/36. So we have 19/36 remaining, and she spends 1/3 of this on clothes. So she'll be left over with 2/3 of this remaining. So the amount that she saves is equal to 2/3 of this 19/36. Now remember, whenever we talk about of in mathematics, we're talking about multiplication. We're talking about multiplying and timesing. So we get 2/3 times 19/36. Again, we can use our calculator to do this for us. And if we pop that into the calculator, so again, just using my calculator here, there is no need to do non-calculator methods for a question like this. And if we pop it in, we then get 19/54. So this is the really important fraction. She saves 19/54 of this particular X. However, we know what 19/54 is equal to, because we're told she saves $152. Therefore, we know 19/54, that's going to be equivalent to the $152, but we want to work out the whole amount. We want to work out 54/54, a whole one. Notice this process I used actually in the very first question in this particular extended question. So again, how do we get to this? Well, we can do it in the same way we did before. If we divide by 19 on both sides, this is so-called a unitary method, we can then work out, well, this cancels, we get 1/54, and that will give us a certain amount. And then what do we do to 1/54 to get 54/54? Well, we multiply by 54, making sure we do the same process on both sides. So this is now where the calculator comes in. We've set this up in this 3-stage process, and now we can just work out the answer. Okay, so all we need to do at this point is type in what we've written. So we get 152 divided by 19, and then we are going to times by 54, giving us our final answer of $432. Again, we can write in the intermediary step if we need to show the working, but this amount of working is more than enough to get all the marks. You're going to see this 3-step process again and again and again in this video. It's one of your big tools for any percentages question. And on to part D, so retesting a lot of different skills here. So Karga invests $500 for 5 years at a rate of Y% per year simple interest. So it's the first time we've seen interest in this video. Remember, simple interest means, again, it's not compounded. So we don't include the extra interest in our next lot of interest. Again, you're going to see this in a lot of different questions. And the value of Karga's investment at the end of this 5 years is $530.75. Find the value of Y. So the first thing we want to work out here is the total interest that she earns. And the way that we do that is we take the final amount and we take away the original amount, the $500. If we do that, we get then $30.75. And then we want to look at the interest that Kara makes per year. Well, how many years was this investment for? This was for 5 years. So we take our answer and we're going to divide it by 5 then to work out how much interest she made in a particular year. So 30.75 divided by 5, and we get $6.15. So once we know that's the amount of interest that she makes in 1 year, we want to work out the percentage that is increasing by. The way we would do this, so we're going to find this percentage interest, and the way we will do this is we'll take the 6.15, the answer we got before, divided by original, so that's going to be 500, and then times by 100 to ensure we get a percentage at the end. So let's pop it in the calculator this time and see what we get. So we've got a calculator here, we pop it in. So again, use that fraction button. It's very, very useful. So 6.15 divided by the total amount, which was 500 here, and again times by 100. Don't feel like you have to use non-calculator methods. Again, as long as you're happy using the calculator, understanding what you're doing, it's going to speed you up. So we get our final answer here of 1.23%. So we pop in our answer of 1.23. Notice our answers in this entire question, we're generally getting either whole numbers or just strictly 2 decimal places. That's usually a good sign that you're on the right track with these questions. Okay, so you can check all the answers that I've gone through here. It's a really good meaty question. You can see you're getting 10 marks on this question, and this could really make a difference between a B and an A grade or an A and an A star. Okay, and on to our next question. So Sachin earns $63,000 per year before paying tax, and he pays tax on his earnings at a rate of 16%. We need to work out the amount that Sachin has after paying tax. So essentially he's got this $63,000, and then we want to reduce, because remember tax is a reduction of 16%. So to translate this into a standard calculation, we want to reduce $63,000 by 16%. So in order to work this out, again, we work out in a similar way to our previous question. So we have 100%, and we want to minus 16%. So how much percent will he be left with? Well, that's going to be 84%. What will that be as a decimal? Well, that's going to be 0.84. So to make our calculation nice and straightforward, all we need to do here is 63,000 and then multiply by 0.84 to work out how much he gets after tax. So we go 63,000 times 0.84, giving us our final answer of 52,920. So we pop that in. So Britta here has a slightly different situation. So she has paid $60,480 per year after paying tax at a rate of 16%. And we want to work out the amount that she has before paying that particular tax. So notice in this case, we've already got this 0.84 from the previous question, that this 84% is equal to the 60,480. And what we want to find here is that original amount. So we want to find the 100% that she had before paying tax. Now, as soon as we've got that set up, just like we've seen in the previous question, what we can do now is work through this three-step procedure. So what do we do to both sides at this point? Well, we're going to divide by 84 on both sides. That then gives us 1%, and then what do we do to 1 to get to 100? Then times by 100. So again, making sure we do the same to both sides, getting that 1% from the original calculation and then working that out, that original. Remember, we're looking for before paying tax, so we're going into the past. All right, let's go to my calculator and work this out. Okay, so we followed the instructions from the question. So we've got 60,480. We're going to divide by 84, and then we times by 100. Making sure to use the calculator correctly here. Not sure what exactly went on there. There we are, and we got our answer here of 72,000. Again, getting a whole number or a number without lots of decimal places is usually a very good sign you've got the right answer. So here we've got 72,000. Then we do a double sense check here. So she had 72,000. We take off 16%. Does that give us roughly 60,480? Yes, it does. Talking about 15% off here. So always use that double sense check to help you getting that right answer. Now, Sachin and Britta do have some savings accounts as well, which we're going to look at in this particular question. So Sachin opens it up with $1,500 on the 1st of January, and it pays 1.8% per year simple interest. So we've seen that phrase before in the previous question, and we want to work out that he has 1,581 at the end. So the first thing we're going to do is work out 1 year simple interest. That's going to be the first thing that we can calculate here. And the way that we do that is find 1.8% of $1,500. Now remember, 1.8%, if we take that over here, if we convert that into a multiplying decimal by dividing by 100, that's going to give us 0.018. So to work out 1 year's interest, we take 1,500 and then times by 0.018. So we can pop that into the calculator, and that's going to give us 27. However, we want 3 years of interest here. So 3 years is going to be taking that previous answer and then just timesing that by 3, which then gives us 81. Therefore, the total in the count, so total after 3 years, will be the initial 1,500 deposit plus this $81 of interest, and that gives us 1,581. It's always so satisfying in a question like this to have a show that question where you do get to the correct answer at the end. Britta also has her own savings account, and now it's the very first time we get to actually look at something called compound interest. Essentially, we get interest on the interest. So that's the key idea here. And the account pays 2% this per year, and Britta pays $500 into her account on the 1st of January every year. So that's going to change slightly the calculations we're going to do. So find out who has the greater amount, so Sachin or Britta, at the end of the 3 years and give the difference correct to the nearest cent. So the first thing we need to do is work out how much Britta has after 3 years. So in this kind of problem, we can just structure this by working out the first year, and then the second year, and then the third year as well. So there is a formula for compound interest we need to be aware of. Remember, if we're increasing by 2%, well, 100% plus 2%, that's equal to 102%. And if we divide that by 100, we then get the multiplier, which is really important here, of 1.02. So the first year, we're going to do 500 times 1.02. That will then give us the total amount that Britta has in her account after 1 year. So that gives us then, if we do that with a calculator, $510. Now we have to read the question carefully. So she pays in 500 into her account every year. So for the second year, we're going to have 510 from the last year. We're going to have 500 from this year. That gives us 1,010, and we're going to times it by 1.02 again. Having this structured approach makes it much easier for the examiner to give you all the marks. So we times that by 1.02. This time we get 1,030.20. Then the third year, again, we add another 500. Again, the 1st of January, that always is happening. So we get 1,530.2 times 1.02. Again, pop that into our calculator, and we will get 1,560.804. So that's our final amount after 3 years. Remember, Sachin, if we go back, he made $1,581. So the difference between that, so we're going to take away 1,581 from the answer we just got, and that gives us 20.19. Again, we want to do it to the nearest cent here. So 20.196 rounded to the nearest cent will be 20.20. So $20.20, and it is Sachin that's got more than Britta in this case. So Sachin has got the most amount of money, but only by $20.20. Okay, so you can check through all the questions that we've gone through so far. So I'm going to have a good big 10 marker, and you can see the same skills are coming up here. This reverse percentage change, the use of the 3-step procedure, knowing the difference between simple interest and compound interest, and we're going to reinforce that as we go through the next questions. Okay, so in a sale, a shop reduces all prices by 12%. Dina buys a book which has an original price, so this is a clue here, of $6.50. Calculate how much Dina pays for the book. So if we're reducing by 12%, well, if we've got 100% and we minus 12%, then we have then 88%. As a decimal by dividing by 100, that gives us 0.88. So to work out the new price Dina pays for the book, we do 6.50 times 0.88. So we pop that into our calculator, and that's going to give us $5.72. Okay, so this question you're seeing here is very, very typical. You've got a normal calculation, you have original price to sale price, and now this part 2 for Elu pays $11 for a toy. Calculate the original price. We're then going to be working backwards. So if we reduced all prices by 12%, the new price, this $11, that's going to be equal to 88% of the original. But we want to find the original price. That's the clue in the question here. So we want to find 100%. And you've seen this process before, working backwards in time. So we want to then divide by 88 on both sides. That will then give us 1%. And then what do we do to 1 to 100? We get to 100. So setting it out like this means you won't make a mistake going through this kind of question. So let's pop this into the calculator. Okay, so we have 11 divided by 88 times by 100. Again, we're getting a whole number answer here, which is always a very good sign. So we get 12.5, so $12.50. So we pop that in. Again, a very standard 4-mark question here, where 1, you're working out the end price, and then 1, the original price. Okay, and on to some typical investment questions. So Ferry here invests some money, and the rate of interest for the first year is 2.5%. And at the end of the second year, the overall percentage increase of Ferry's investment is actually at 6.6%. And we want to work out the rate of interest that achieved that 6.6%. So the first thing that comes to mind here is we want to increase this by 2.5% in the first year. Well, if we're increasing by 2.5%, that's 102.5% in total. So if you divide by 100, it gives us 1.025. So in order to work out the overall percentage increase, the first one would be in the first year is 1.025 times some x. So x is the initial amount of money that I've started with. And then for the second year, I've got this amount, so 1.025x. And then I'm going to increase it again by another interest rate. We're going to call that R. And if I add those together, so the total from the first year and the total from the second year, that's going to be equal to an increase of 6.6%, which is going to be 100% plus 6.6%, which is 106.6%. And that gives me 1.066. So 1.066x, so of the original amount of money. Now notice we've got an x in everything here, which is very useful, so we can cancel through. That gives me then just an equation to solve here, which is 1.025 plus 1.025r is equal to 1.066. And now we just approach this like an equation. So it is an equation. So all we do is we minus 1.025 from both sides. This cancels, leaving us 1.025r. And if we take one away from the other, we get 0.041. But we want to work out this specific rate of interest. So we do the opposite of timesing by 1.025, which is dividing by 1.025 on both sides. This cancels, giving us r is equal to 0.041 over 1.025, which if we pop it into the calculator, we're going to get our interest rate of 0.04, which as a percentage is going to be equal to 4%. So the way to approach this question is, for anything that you don't know, just put a variable, in this case x, and then by constructing the situation read from the question, this problem-solving technique, then you can find a method that works for you, which then gets through to the right answer of 4%. And part D, which is often on the 0580 papers specifically, is this idea of exponential decay. Okay, this works essentially in the same way as depreciation or compound interest, but going downwards instead of upwards. So a radioactive substance decays at an exponential rate of 2% per day. The initial mass is 80 grams. Find the mass at the end of 5 days. So all we need to do here is take the initial mass, the 80. Now, if we're reducing by 2%, then that's going to be 100% minus 2%, which is equal to 98%. And as a decimal is 0.98. You see this technique again and again. So we've got 0.98. And because we've got exponential decay, then we raise it to the number of days that's happening, so to the power of 5. So we're going to pop this into our calculator, and you'll see exactly where you can find this button to raise it to the power of 5. So we get 80 times, get the brackets out here, 0.98. And the button we're looking for is this chevron key here. So we click on this and it allows us to put any power that we want. We want to work with 5 in this case, giving us our answer then of 72.31. And generally we round this to one decimal place, so we're going to get 72.3 grams. And a nice little follow-up question to this is find how many more whole days after day 5 it takes for the mass to reduce to less than 67 grams. Now you could do this using logarithms, but on the 0580 course it's not on there, and 0607 it is being taken off. So the best approach then really is to do it by trial and error. So what we do, we have our equation, and all we need to do is try out different numbers until we get close. So after day 5, it's 72.31 and we want less than 67 grams. So let's just try 8. Again, we want a number bigger than 5, and we can try that out in the calculator. So 0.98 to the power of 8. Excuse me, that gives me 68.06. So that's still too high. So the next one to try would be 80 times 0.98 to the power of 9. This trial and error approach works for quite a few questions. Again, not the most efficient, but it will work. So we get 66.699 ... This is just fine. So this is lower than 67 grams. Again, we want it in whole days here. So we started at day 5, at the end of day 5, and we've got 9. So we just do 9 minus 5. So it happens after day 9, but we want how many more whole days? So 9 minus 5 is just equal to 4 days, like so. This trial and error approach, again, it might take a little bit of time getting your calculator set up, but you will get to the right answer at the end. So you can check all the answers. Again, another big old paper 4 question. So we've got 7, 9, 11 marks for this particular question. All right, on we go to question 4 here. So Zach invests $500 at a rate of 2% per year. Simple interest. Very important to be reading this carefully. And we want the value of Zach's investment at the end of 5 years. So we want the simple interest. I'm going to write that just to remind us here. After 1 year, and the way that we calculate this, so we have 2%, so essentially we want to find 2% of $500. Now again, we can use the multiplier method, which is the 0.02 times $500, or we can use that sort of non-calculator method of find 1%, which would be 5 times 2 is 10. So this is going to be equal to $10. So after 5 years, well, we just times this by 5 to give us 50, and therefore the whole investment, so the total is the 500 that we started with, and then we add on that 50, giving us $550. Quite surprised this is a 3-mark question, to be quite honest, but take those marks when they come along. Now Yasmin, however, invested at 1.8% compound interest, which is worth reading, and we want the value of the investment at the end of 5 years. So again, knowing this formula is really, really important because it's not on the formula sheet. So we have 500. Now we want the multiplier when increasing by 1.8%. So increasing by 1.8%, we're adding it to 100%. That gives us 101.8%. Too many percentages. There we are. If we divide by 100, then this gives us 1.018. This is the key number because we're going to pop it in here now, and then we raise it to the number of years. So in this case, 5. So we pop that into our calculator, 500 times 1.018 to the power of 5. That gives us then 546.649. Because it is money, we're going to round this to the nearest cent. So we get $546.65 for our 2 marks. Now, the next question, again, is a nice follow-up question to this. So Zach and Yasmin continue with these investments. How many more complete years is it before the value of Yasmin's investment is greater? So we want Yasmin is greater than the value of Zach's investment. So if we go back at the end of 5 years, we've got $546.65. And here we've got $550. So we've got different ways of being able to work this out. Again, we can take a trial and error approach. So if we divide this into a table, this is Zach, this is Yasmin. Now working out Zacks is going to be the easiest because we're adding on $10 each time. So remember 5 years, which is going to be our base here, it's going to be $550. And for Yasmin, 5 years is how many? 546 and 65. And so working out Zacks, again, the simple interest here, so we keep adding on $10 each time. So we've got 6, 7, 8, 9, 10. So we have 560, 570, 580, 590, 600. And what we're aiming for here for Yasmin is when this one is greater than this side over here. Now remember the formula that we used? We used this 500 times 1.018, and then we are changing this number to see if we can get it more than the left hand side. So setting this out carefully is the most important thing. So let's try a number. Let's pop in 7. Again, doesn't matter where we start. So we're going to do 1.018 to the power of 7. That gives us, for this one here, $566.51. Again, still too low. We can try then to the power of 9. So that here gives us $587.08. And again, we can keep trying different numbers here. We can try then to the power of, say, 12. So for 12 years, I'll pop this down here, that's 619.36, which I think is just a little bit less of what we need. So it's probably going to be the next year, so it's going to be 13. So this is 630. Again, this method will work because particularly with a calculator, you can just change numbers very, very quickly. Again, you can set this up algebraically too. Yep, we get $630.51. So here is where it is greater, and we want how many more complete years is it before it's greater. So really read the question carefully here. It is the 13th year, but we're starting at 5 years. So we need to do 13 minus 5, which is equal to 8. So it's 8 extra years that are required in order for Yasmin's investment to be more than Zach's investment. And on to the next part of the question. Again, you didn't think this was finished by this point. So Xavier buys a car for $2,500. The value of the car decreases exponentially, again a key word, at a rate of 10% each year. And calculate the value of Xavier's car at the end of 5 years. So because we're decreasing by 10%, remember if we're decreasing by 10%, that's going to be 90%, which as a decimal is 0.9. And now we essentially use the compound interest formula we saw already. So we have 2,500 times our multiplier, which we just worked out, at 0.9, and then to the power of 5. So we pop that into our calculator. Again, as you're going through these questions, you're getting to see more and more of them. The key thing here, and that's going to be 1,476.225, and we want this to the nearest dollar, so it's going to be 1,476. Again, for a 3-mark question, there's not too much working to do here, so you can really boost your marks by being really, really effective and efficient with these questions. And the next part of the question, so number of a certain type of bacteria, this time increases exponentially at a rate of R% interesting each day. After 22 days, the number of this has doubled. And we want to find the value of R. Now, it feels like in this kind of question that we don't have enough information. But let's just give a letter to things that we don't know. So we'll say the number of bacteria at the start. And we'll say at start is equal to P. So we'll just give it a letter. So if we follow this instructions, we're increasing, but we'll come back to the multiplier in a moment. But essentially we're doing P times something. Let's just call it M for multiplier. And after 22 days, so to the power of 22, It's doubled. Now we know what it starts at. We know it starts with p. So double p is just 2p. And actually, we've got an equation that we can solve. The reason is that we can cancel p from both sides. So we can cancel a p here and cancel p there. Because both sides of the equation, you can cancel the factor. So we get m to the power of 22 is equal to 2. This is an equation that we can solve. The opposite of to the power of 22 is the 22nd root of it. And that looks crazy, absolutely crazy. But I'm going to show you on the calculator that we can actually work this out. Okay, so on the calculator, I'm going to press Shift and this button here by the chevron that we saw before, and you can just pop in 22. So your calculator is effective at working these things out. And if you press the answer, we get 1.032, which I'm just going to write in. So 1.032 ... Now that's not the answer, because we need to work backwards to steps that we've done before. So if I take my multiplier of 1.032 ... we times by 100, that gives us 103.2 ... And what is the multiplier here? Well, what do we add to 100 to get to 103.2? Well, we have 3.2%. So that is the exponential rate that the bacteria are actually multiplying by each day. So we have to be very careful when we do get our answer here that we convert it back into the percentage increase that we're actually looking for. Okay, so you can check your answers from the very first part of the question and then the next part of the question. So you can see 3, 6, 9, 11, 14. Lots and lots of marks available for this kind of question, and you want to be picking them up. Right, on to our next question here. So at a football club, season tickets are sold for seated areas and for standing. The cost of season tickets are in the ratio seated to standing is 5:3. The cost of a season ticket for the standing area is equal to $45, and then what the cost for the seated. So we have the ratio 5:3. Let's put seat and stand. We know the cost of standing is 45, but we don't know the cost of seating, the question mark. So this is all about setting up your ratio correctly here. So what do we do to 3 to get to 45? Multiply by 15. So you want to do the same to both sides. This will then work at the mystery question mark. So we need to do 15 times 5. That will again give us, again on the calculator of course, $75. So I thought I'd include this very small part of the question because most of it is percentages related, but a little bit of ratio doesn't hurt either. Now on to the percentage part of the question. So in 2021, the value of the team's players was 2.65 million. That's a lot of money. In 2022, this value decreased by 12%. Find a new value here. So if we're decreasing by 12%, you know the procedure at this point. So 100% minus 12% is equal to 88%. This is the decimal is 0.88. So all we need to do here is take our 2.65 million, so 2,650,000, and then multiply this by 0.88. So we pop it into our calculator, and this will then give us the answer of 2.332 million. Again, if you actually work this out in long form, it will look like this, but it wants it in millions. So you need to make sure you put the decimal point in here too. And the number of people at a football match is 1,455. This is 6.25% of the total number of people allowed in the stadium, and we want to find how many people are in the stadium. That means we have 6.25% is equal to 1,455. We want to find 100%. Again, we've got that three-step procedure. So we want to find 1%, so we divide by 6.25 on both sides. That gives us the 1%, and then we times by 100. This method works again and again and again. So if we do the right-hand side here, we get 1,455 divided by 6.25 times 100, and that gives us a good whole number. That's looking good, 23,280. So we pop that in to 23,280. And our very last question here, so the average attendance increased exponentially by 4%, again exponentially keyword, for the 3 years from 2016 to 2019. And in 2019, the average attendance was 1,631. And we want to find the average attendance for 2016. So we then know, we don't know what the initial attendance in 2016 is. Let's just call that X, but it increased exponentially by 4%. So it's an increase of 4%. So a multiply of 1.04. And that increased over how many years? So 17, 18, 19, so 3 years. And that then gives us 1,631. Therefore, X on its own, what's the opposite of multiplying by this? We're dividing by it. So we get 1,631 divided by 1.04 cubed. So again, we can use the calculator for this. So 1.6. I don't know why I keep putting a decimal point in. Divided by 1.04, again, cubed. And that gives us 1,449.95, which when rounded, again, we can round to a variety of different things here, but I think to the nearest whole number, 1,450 is the most sensible rounding here for this particular question. Okay, you can check all the answers that we've gone through in this particular video to make sure you're happy with the mark scheme. Yeah, another big chunky question here, so we've got a good old 9 marks. If you need to revise your algebra skills, then I do recommend you look at the video right in front of you, because this will get you up to date, just like it has with percentages, but also for your algebra skills as well. Both topics really, really crucial for those paper 2s and paper 4s.